So it's little tables you need to remember. Here, the derivative of sine is cosine, and cosine is minus sine. And derivative of tangent is secant squared, and for cotangent is minus cosecant squared. The derivative of secant is secant tangent, and for cosecant is minus cosecant cotangent. You can see on the right hand side, you always need to put a negative sign there. So as a result, I can just because for instance, the derivative for sine is cosine, so the antiderivative for sine for cosine would be sine, meaning that if I just integrate sine, integrate cosine, okay? You'll get sine x and plus a constant, an arbitrary constant, because the derivative of sine is cosine, okay? And also the integral of secant x dx will be equal to tangent, okay? We can do the same thing here. So from here, the integral of cosine will be sine, because the derivative of sine is cosine. And from here, we know that if you are taking integral of sine, you will get minus cosine, okay? And from this one, so from this, okay? From here, so integral of secant square will be tangent. And from this one, integral of secant tangent will be secant. And here, integral of cosecant square will be minus cotangent. And integral of cosecant cotangent, you will get minus cosecant. Okay. So that's some very fundamental thing. Okay. So what we have, this one is the this is the presentation, the presentation I have. Someone here, you have the this sine. So we already have sine, cosine, the integral for sine and cosine, and we still need the integrals for secant, tangent, cotangent, secant, cosecant. I will deal with that later. First of all, let's try a few examples here. Okay, let's look at the example here. Now this one. Let's try something, some easy one first. First of all, 3x squared sine 2x to 3 power dx. And we need to use the integration by substitution here. So first of all, that u is equal to x cubed into 3 power, and then the u will be equal to 3 squared dx. So this will be equal to what? Equal to 3 squared dx, which is the u. So we will get the u, sine u du. And we know the derivative for cosine will be minus sine. So integration for sine will be equal to minus cosine u plus a constant. Will be minus cosine x to 3 power plus constant. Now let's this one. Okay, try the other one. Eight more minutes. Okay, so the next one will be secant 3u tangent 3u. Okay. I'm sorry, this is 3x not u. Let's finish the first part of recording. So here with a similar moment. So secant 3x and tangent 3x dx. Okay? And you remember that where? Here. The integration of secant tangent with secant. Okay? So secant tangent with secant. So we let u equal to 3x. So imply the u equal to 3 dx. So this should be what? It will be equal to 1/3 secant u tangent u du. So be equal to 1/3 of, because is integration of secant tangent with secant. So be 1/3 secant u plus constant. So be equal to 1/3 secant 3x plus constant. Okay? So which is not too difficult. Just use use the table here. Use these. Just the some intervals involving trigonometric functions. So you get And let's try the next one. This will be e to the x. Secant square dx. First of all, we notice that that be involving secant square. And we do know the derivative of tangent is secant. Okay, so secant square, integration of integral secant square be tangent. So this gives us a hint. So I like you, just here. The derivative of ex will be derivative of ex is equal to e to the x. So with a u equal to e to the x power, I can imply the u equal to e to the x dx. Therefore, this will be equal to secant square u du. So be equal to tangent u plus constant, so be tangent e to the x power plus constant. Okay? So basically, just need to recognize these basic tables for the integration for integrals. Still, however, just try to just provide help, assistance for you to pass this calculus class. All I have done, just try to do that. Okay, let's try this one. This is probably the last example before we take a break. This script is a little bit difficult. It's a little bit sine square 4x and cosine 4x dx. Okay. But here, you know the what? Question? Oh. Here you see that. Just observe that the cosine will be derivative of sine. Cosine derivative of sine. Okay, so this gives us some hint. So we'll let u equal to sine 4x. Okay, so I can imply the u equal to cosine 4x and multiply by use the chain rule, so it's the need to take derivative of this 4x. So I need to multiply by 4. Okay. So here will be equal to 1/4 of this. I need to have 4 to make it du. So I add 1 divided by 4 here. And so it's sine square u du. Okay? Then what's next? No, it's not. Sorry. Because u is sine is sine 4x. So here will be u squared. Okay, yeah. So u is sine 4x. So this will be u squared as du. So I get the 1/12 u to the 3 power plus a constant. So be 1/12, and that'll be sine be 3 power 4x and plus constant. Okay. Integration of sine 1 cosine, okay? Let's look at this one. So here, like say we do know the derivative of cosine is my sine. So from there, you can see I can let u equal to cosine x. So apply the u equal to my sine x dx. Okay? So what we have, you will get this will be 1/u, but here because I have my sine here, I have my sine, and there's sine dx, so I put my sine here, u. So I will get my natural log u and plus c, plus a constant. Okay, so we'll get my natural log, which will be absolute value of cosine x plus c. And this one, and this is what this will be. So that's the integration of tangent x dx equal to that. Okay, so I think you should be able to integrate cotangent. Probably very similar to this. So there. So this one I'll let you do it at home. So here, that's your homework. You do it at home. The integral of cotangent, you get the natural log of sine. That's the value of sine x dx. Absolute value of sine x and plus the constant. Okay, so you're doing just you can solve this using a very similar method here. Okay, so we will do this one at home. Okay, work on this one. And this problem is just I want to find the area of the region bounded by x-axis and the graph of y equal to sine x for in a range of 0 or less equal to x less or equal to pi. I can draw the graph here for sine x. From 0 to pi, that's 1, that's pi over 2, that's pi. So let's see let's y equal to sine x. Okay? So basically we just to integrate from 0 to pi and sine x dx. Okay? And we do know this will be equal to minus cosine x. And just the evaluate from 0 to pi. And remember, you just recall that the cosine is what? Cosine would be negative in the second quadrant. Okay. So I will have minus sine pi and minus cosine 0. So would be minus of that's the minus 1, and it'll be minus 1. So the answer will be 2. Okay? This basically is just there's a part. There are also other examples to integrate the trigonometric function, but you need to evaluate the lower limit and upper limit, which will be a different interval. Also, I already posted the equations of number 8, chapter 8 on the e-learning, so you can just log into the e-learning to check out. Okay. This page will be tangent for x dx, the integration of tangent for x dx. And the answer is very close, very similar to this one. But I have need to multiply the 1/4 instead negative natural log and cosine 4x plus c. Because they're too similar to this, this problem, this question. So I will let you work on this one. Work on this at home as well. I'll do this at home, do this at home. The answer I will already provide the answer here. Or 3 and 6 more. Okay, try the other one. We have interval for sine, cosine, and tangent. Again, work on cotangent at home. Now let's look at the integration of secant. equation of secant. This is a bit difficult. Secant x dx. I think for this one is just you have never seen anyone have never seen the proof for this. I think it's difficult for you to solve it on your own because it's kind of tricky. Let's see. They involve because we know derivative of tangent is secant. Derivative of secant is secant tangent. Okay. Derivative of tangent is secant square. Derivative for secant is secant tangent. Okay. Interesting. So let's do this. I'm going to multiply this to see. I have a secant x plus tangent x. Here, secant x plus tangent x. I multiply this by secant x plus tangent x, then divide by the same thing here. Okay. So what you get? You will get secant x plus tangent x, and on the top will be secant square plus secant x tangent x dx. Okay? And see, here's a magic part. Derivative of tangent. Derivative of tangent is secant square. Derivative of secant is secant tangent. See there? So what you get, let's divide that. U equal to secant x plus tangent x. Du equal to secant x tangent x plus secant square x dx. So this will be du. This will be du. Okay. So get the, so imply that will be the u over u. So it will be equal to natural log absolute value of u plus c plus a constant. So be natural log secant x plus tangent x. I need to take the absolute value before I take the natural log. Okay, so let's say this. So this one is the cosecant x dx, and the answer will be minus natural log as value of cosecant x plus cotangent x plus can please do it by yourself, okay? Really work on that as a homework. It will be similar to this one, very similar. Okay? Two, 20
second.
huh?
20 second.
Yes, so that's 1 third minutes. Okay, so basically we have, let's just review a bit. So the integral of sine